Hello, everyone, and welcome to the monthly demo. My name is Brad LaPorte, and I am here today with Darren, our Senior Security Sales Engineer. So I am the Chief Marketing Officer at Morphisec, and today we're going to be going through and seeing how to proactively secure Linux systems against ransomware attacks. And this is our monthly demo. So if this is your first time joining us, every month we go through a specific use case and we showcase, how best to go about that use case and basically really seeing Morphisec in action. So Darren, thank you so much for joining us. I really appreciate it and bringing your expertise.
Sounds
As
good.
part of this, all right, let's dig into it. So, first I'll start off by saying, we're getting into a ransomware epidemic, and ransomware is an evolving business, and it is relentless, and it's not going away. With the adventation of artificial intelligence, with the shift across the multiple attack surfaces like Linux, reactive security is just flat out failing, and it's overwhelming security teams. And threat actors are able to leverage endpoint vulnerabilities and different weaknesses, and these different devices are remaining unprotected. So the traditional model of detect and respond is no longer adequate, and this is driving up the high cost of ransomware overall. And we're seeing an increase in the average ransomware payment and the median ransomware payment over time. And really, two out of three payments are occurring because backups failed. So the traditional methods are just flat out not working from a detection response perspective, but also from a backup recovery perspective. And in addition to this, one out of three payments have also been driven by the desire to prevent the release of exfiltrated data. So data exfiltration is becoming another facet. We're seeing a rise of ransomware as a service, as well as very uh, basically different variants of ransomware. And then obviously Gen AI and different artificial intelligence ransomware groups are leveraging that as well as prompt injections into an environment. Linux has a unique environment, and I'm going to hand it off to Darren in a minute in terms of like how this looks. But why this is so unique and how really organizations can proactively prevent against these types of attacks. But it really think of Linux as a new ransomware battleground. Historically, th- organizations could leverage Linux as being, a safe haven, due to the fact that it wasn't targeted. But now that 80% of public cloud workloads run on Linux, and over 96% of the top 1 million web servers run on Linux, ransom operators are now building Linux native payloads to attack. And they're going after those mission critical data. That's where the crown jewels are. So this is why Linux is under siege. They're looking at the fragmented environments. They're looking at unpatched and legacy systems. They're looking at misconfigurations. They're looking at cloud and DevOps acceleration. So there's a new ransomware playbook that's at play, and it's double extortion by default. It's fileless and in-memory execution. There's living off the LAN, polymorphic payloads, and cloud-aware ransomware. And this is exploiting the different hidden weaknesses in your Linux stack. So weak identity controls, container misconfigurations, open source supply chain exposures, cyber physical systems like IoT, OT, IIoT, all the OTs, and really those edge devices, as well as consistent logging and monitoring. And all of those items are moving laterally or getting to your traditional end goal, which is the servers and the server side of it and the Linux infrastructure. So if you look at it from a real world perspective, we're seeing a lot of momentum in that area. So held down ransomware was expanding attacks to VMware and Linux hosts. We had BERT ransomware, which was leveraging ELF files, and then jackers leveraging you're really running undetected for months in Linux systems. And then, as stated before, AI-driven reconnaissance or credential theft. And all of this is being extrapolated exponentially through supply chain attacks and abusing, really trusted open source ecosystems. So why detection really is failing, it really comes down to fileless malware leaves no disk artifacts. So memory resident attacks, you're being able to bypass behavioral detection. Polymorphism, really breaks signature and IOC-based tools. And it really makes things a lot more complex, as Darren's going to talk about. And then, it's resource constrained. Resource constrained Linux servers really can't handle heavy agents. It's really difficult to, do those constant updates and the care and feeding that's needed. So by the time that detection fires, the data is already gone. And then last but not least, having the prevention first model. So things like automated moving target defense, having memory shielding, high value decoy traps, zero noise for protection, and then really having it across your entire ecosystem, it really rounds out and provides the best level of protection. So without further ado, I am going to, really hand things over to Darren, and we're going to dive into this and see it live.
Sounds good. Any particular reason why it's not letting me share?
1 second, please.
Oh, I got it. We're good. Stop 3. There we go. Sorry about that.
All
Okay,
right.
can you guys see my dashboard here?
Yes, sir.
Okay, we're going to get back to this host in a bit, but I do want to start off with talking about basically the architecture of how we integrate with Linux. So when you think about traditional tools, a lot of them are still taking a legacy approach, right? Doing that file hashing and hooking and whatnot. Well, not hooking, but file hashes. Linux, a couple of years ago, starting back around 2014, they introduced something called the ePPF kernel module. But the big thing to keep in mind with Linux is they really have a big separation, similar to Windows, between user space and kernel space. And anytime you want access to any of the resources, whether or not it's a keyboard, the hard drive, the monitor, or anything for that matter, it's done from user space where the application is executed into kernel space through what's called a syscall. Now, what we do here at Morphisec is we actually integrate directly into that kernel module that I talked about, right? The ePPF kernel module, extended Berkeley packet filtering system. And that allows us to run code securely within their environment, like within the kernel itself. In turn, that gives us the ability of doing kernel hooking, which allows us to do that tracking, probing the data, doing the package data analysis of identifying and understanding all the different applications that are installed on the host. That basically leans into adaptive exposure management, which provides analysts the ability of understanding what tools are there, where the vulnerabilities are, identifying end of life and end of support software. But that one module also gives us the ability of deploying the decoy files, monitoring them, applying firewall rules, identifying and preventing data exfiltration as well. And more importantly, if there actually is a ransomware attack, which we'll be demonstrating in this session, but being able to intercept any the keys to help recover whatever files might have been impacted. So basically boils down to some simple actions, right? Being able to kill off the more malicious process, sending incident data back up to our management console. Okay. Now, back here in the management, my demo here. This is a Windows host that we're going to be using to leverage to actually launch a remote attack against a Linux server. Now, over here, we do have Morphisec installed, but it's only running in alert-only mode. So I basically want to highlight that we would also have stopped this, but this could be a scenario potentially of maybe an internal threat, an insider threat, I should say, or maybe even a host that was compromised through stolen credentials, remote access through something like social engineering, right? Where they got access to the host. It could even be something that a contractor that got onto an organization, jacked in their laptop, and they were infected without knowing. A lot of different use cases out there. But point being, what happens when you think about from a malware perspective, ransomware, a lot of times they're immediately going to scan the host to identify everything it has access into, okay? And From that point, they're basically going to scan the host completely in order to identify what it has access to and immediately start encrypting whatever it does have access to. Okay. So now that we've established this share, before we do that, let's go over here. We're going to kill this. I'll keep that open. All right. We're going to launch go over to the Linux server. First thing we have to do is install Morphisec. But before we do that, I want to highlight how this is all set up, right? So this is technically the NFS share that this Windows host has access to, okay? Now, the first thing I'm going to demonstrate is locally on the server itself. I want to demonstrate what it looks like when data is exfiltrated out of the network, okay? So here is my Mega console, and Mega is used frequently by adversaries because it's a well-known site, and because it's well-known and used heavily, it wouldn't be put on any type of blacklist. Plus, because all their data is encrypted, that means that even if law enforcement was to get involved and they were to get access to the account, they can't see anything because it's all encrypted. Now, what I'm going to be doing here is demonstrating, and if you notice here, it automatically is going to create a host name along with the timestamp. So we're going to see a new one pop up. Okay. Now this script is leveraging a couple of different tools, but it's going to try to exfiltrate the data off that host and push it up to the cloud. Second I launch it, you can see that data exfiltration occurring with a new folder, in fact, being created right here. Okay. Now, with that being said, let's install Morphisec. And a couple of things that I want you to take note of. First, very lightweight package. The package itself will identify what build that you have, like which vendor you're running, immediately go up to the repositories, download any tools that it might need that we know that we need, and install them. We also have one package that contains all of our dependencies. It's really up to you. So if you have a segmented environment that might not be able to reach out, you can actually leverage one of our pre-built packages that have everything installed. Okay. Now, install typically takes about a minute, and the key thing to take note of is it won't require any reboot. We immediately go to work. Now, as soon as the services do start up, we're then going to replicate that same attack of the data exfiltration just to demonstrate that we can kill it. Okay, it's done now, and we're going to replicate that same thing we did before, data exfiltration. And again, going back to the Mega console, if it does successfully exfiltrate, we'll actually see a third directory pop up over here. Now go over here, execute that tool I wrote, and you can immediately see that it was killed along with the process ID. We'll review that more in a bit. You go over here, you don't see any new folder here. Go back over to our management console here. We went over to our incidents. We should be able to see that remote data exfiltration actually being killed. Now notice how we show the entire attack chain as well. Now we'll get back to that in a bit, but now let's switch over to demonstrate a remote ransomware attack. So again, to highlight the use case here, this host could have been compromised in any way, but it has access to that NFS share, okay? This is the IP address of that host. And I'm pointing that out because what I want to do is, so you can see here I'm dumping my IP tables, the firewall rules, if you will, in order to highlight that there's currently nothing in place. So what's unique about what we do here at Morphisec is as soon as we identify any type of file manipulation on anything, whether or not it's encryption or even renaming them, we immediately not only kill that process, but add the IP address of the offending host. That's what we're seeing here, okay? So again, this is technically a very live ransomware sample. Second here, we're going to go over to my malware folder. going to go over to the direwolf and we'll execute this one. Now, it actually goes towards the NFS share first. So we're quickly going to see a rule notification pop up. We're not going to see any notification. Well, actually, we will see a bunch of them because it's trying to do encryption, and we have this in alert only mode. So when I go to execute it, you're going to see it all go to work and eventually a bunch of windows popping up. You can see the alert notification happening over here. And on the Linux side, if I rerun that IP rules, we can see, in fact, it already identified it because it already tried to talk it and actually, or take the files or encrypt them. But notice how it already put in a firewall rule to block it. Okay. You can see all the different alert notifications. You can even see the local files being encrypted. So this is, in fact, a really live ransomware sample. Okay. Now, we don't really need that anymore, but let's flash that back. We're going to come back over here. And we can, if I wanted to, I could delete those firewall rules, but right. So now that we've demonstrated both a data exfiltration and a remote ransomware attack, let's see what happens when we actually try to launch a local attack, a local ransomware attack. Okay. So Morphisec is installed. Decoy files are deployed everywhere, and we're monitoring for quite a few other items here, okay? Now, this is another variant of a Babook ransomware attack, but it was specifically Linux focused. Now, when I do go to execute this, you'll notice that it actually immediately forks off in order to maximize performance and impact, and tries to encrypt as much as it can and as quickly as it can. So as soon as that happens, I got a little warning here just because it is a demo. Give me a second here. Once we go to execute this, we'll see that it did in fact encrypt a couple of files. And again, keep in mind that we're trying to mitigate just how bad of an impact. As soon as they touched any one of our decoys, we immediately saw it, put that block rule. But more importantly, we are able to capture the ransomware keys. So if you notice, each file, each one of these files are associated with these individual ransomware keys. What it actually did was something a little bit more ingenious, where it actually forked off, and each file being encrypted is being encrypted with a unique key. But because of where we sit, we can intercept it and provide those keys. So while we not only mitigated how bad of an impact, but working along with us, we can actually help recover those files that might have been encrypted. Okay. Any questions so far? We have anything in the chat? We're doing good?
Yeah, it's a couple coming in, but they're not necessarily we'll cover it at the end, not on this demo at this particular time.
Okay. Sounds good.
Yeah, so if anyone has questions, please dump it into the Q&A section of in your Zoom chat. But thank
Okay.
you to everyone that's submitted it so far.
So from here, let's go over to our management console, right? Because it's all about having that visibility. First and foremost, as soon as the incident is prevented, the user will get a pop-up notification, with exceptions to the Linux piece. But we cover pretty much all the major vendors from a Linux perspective, as well as all the Windows platforms, from Windows 7 all the way up to Windows 11. On the endpoint side, server side, 2008 R2 all the way up to Server 2025. It's important to also understand that we believe in deploying us on everything, everywhere, because adversaries are trying to find whatever vector they can to breach into an environment. Now we have our two main dashboards that's meant to summarize our adaptive exposure management. So if you remember, one of the first things we do when we are installed is actually do a complete software inventory of whatever's running on that endpoint. That allows you to correlate and understand and even identify potential risky software. We can also see running processes that are running on the endpoint. Now, anything we're seeing running in here means it's actually not an installed application, but typically a standalone tool. So for example, if I went over here to vendor type and did a filter on Linux, we can actually see just those Linux hosts here, along with the full path of where they were executed from. Doesn't necessarily mean that they're malicious, but it gives you insight if you're trying to do an investigation. Now, we will identify, I don't have any in this environment here, but any type of end of life or end of support software for both Windows as well as Linux. This is very different than vulnerable software and a lot of times can go unnoticed by organizations, especially if it's not being used or anything to that effect. What's nice about Morphisec, both on the Linux as well as the Windows side, you can't hide from us. Not only will we pull the installed applications, but we'll also identify the vulnerabilities and identify whether or not the application is being used. So while this is a demo environment, I'm not seeing the usage column. In a corporate or real environment, we actually would see this. So while we do provide the vulnerabilities highlighting the CVEs, as well as the probability, while this is a very static value, this one is not. This is updated on a daily basis and is tracking various variables. Everything from whether or not there's a proof of concept code out there, whether or not it's actively being exploited, any of these things will factor into it. And again, this is updated on a daily basis. Now, from a management perspective, what it does is it gives you the ability of actually focusing in on what's real. Proof and pointer, an example. A couple of weeks ago, I was on a customer POV demo where they were very proud of their remediation process for identifying vulnerabilities and patching them. But we installed Morphisec. We identified a server application that was installed and it had a very high vulnerability. Now, what really struck my eye and caught their attention was that the usage column was showing none, which meant that the application, the service, was actually installed, but just not running. But it still highlighted that the vulnerability was still there. So they actually went back to their team and actually found out that it was a tool they forgot to uninstall, but we still saw it. So even if it's a standalone tool or a fully installed, we will see it, map it up, and identify what's real, what's not. Now, even if you're trying to identify specific CVEs, you can search for it here to see if any of them exist. And anytime something is patched within 24 hours, usually you'll see it go away here. Now, it's also important to identify or highlight that we also do have a fully integrated API. So for any of those organizations that have a well-built team that like to customize things, or even a SOAR or SIM platform that might leverage API to pull in its data, pretty much everything you're seeing me do in the dashboard and then some, I can do through an API call, right? So this allows you to enable and empower your SOAR platforms as well to ingest data and take action as you see needed. Okay. Now, that's really about it. We do have a section where you can actually use this to manage the endpoints, both Windows as well as Linux. So for example, you can see here I got a Red Hat as well as a SUSE, as well as my own laptop, which is also running Ubuntu here. Any of them you can see whether or not they're online, their internal, external IPs, a lot of details that helps the analyst understand what's going on here. You can remotely upgrade them by selecting the host. You can even individual group them up, to group them up as a bulk if you'd like. We also are built from the ground up as being multi-tenant capable. So that means if you're a large organization and simply want to segment, you can do it like that, or an MSSP for that matter, being able to manage all of your clients individually, giving them each their own account. And even under that, each account can have individual tenants, allowing you true separation with different integrations. So we have full integrations with SIM. We do have integration with Intune, allows us to provide that visibility of what's installed and running and not. From a Microsoft perspective, we also have integration with Defender for Endpoint. I think we went through that a lot quicker than we thought we would there.
No, we're doing good on time. So we have a couple minutes for Q&A. Is there anything else you wanted to cover before we switch over?
No, I think we covered everything. We went through the different use cases we talked about, everything from data exfiltration locally on the endpoint, what it looks like without Morphisec, with it installed. We demonstrate a remote attack of a ransomware attack, not only preventing it, but also putting in a 24-hour firewall rule to prevent that host from communicating with it. We also demonstrate a local ransomware attack, showcasing not only did we stop and mitigate how bad of an attack it would have been, but also providing those ransomware keys to help recover those files that might have been impacted, right?
Hmm.
And that's really the key point here.
Yeah, this is definitely a master class on how to properly protect your Linux system. So we really appreciate that, and we'll just kind of pivot into the tail end here. So I'm going to share my screen. Um, you can tear down yours, and then as we just kind of recap things, Morphisec, we have a comprehensive anti-ransomware assurance suite that covers not only Linux but also Windows as well, and you have a full spectrum ransomware protection. You're able to maximize your return on investment. You have a faster resolution time due to the prevention angle that we have. And we do have a solution satisfaction. So Morphisec is a future-ready solution. So with preemptive cyber defense, we stop known attacks today and then unknown attacks of the future. So with that, we have enhanced operational efficiency, strengthened trust, and then help you with your regulatory compliance as well. So it's a proven approach. We're adaptive, and we also help with your adaptive cyber resiliency and overall reducing your cost per endpoint. And then it's all backed by a ransomware-free guarantee. So we got the Pure Insights reviews of 5.0. We have thousands of organizations and millions of endpoints in place. So definitely a tried and true solution. So if we kind of pivot into some Q&A, appreciate folks that submitted that. One of the first questions that came up was, what Linux distributions does Morphisec support? And then there's a sub comment. There's another question in here specifically around IBM-I, which was formerly called AS400s, so the mainframes. So you want to dig into that, Darren? I know we have a wide range of Linux distributions we support, and it's quite comprehensive.
Yeah. So for the IBM support question, no. Currently, it's only Linux based systems. Typically, think about it as all the major distributions you can think of. There is certain kernel versions that we need to have, and it's basically anything usually from a kernel version of 2018 on up that has that eBPF piece integrated into it. As long as that's there, we should be good to go. But all the major distributions from Red Hat, Ubuntu, SUSE are all supported, as well as quite a few
Hmm.
others.
Yeah, even some like newer ones like Rocky Linux and there's Fedora, Oracle, Amazon Linux, all the wide distribution of variants. Um, the what about performance impact? Obviously we talked about that. So I don't know if you could dig into, you know, you know, what the overall performance impact of Morphisec is on Linux systems.
Yeah, I mean, that's a great question. We get those kind of questions quite a bit, right? When you think about the way a lot of traditional tools operate, we're fundamentally different. Performance impact is typically negligible because we're not doing that typical activity that EDRs are doing, looking at file activity, comparing hashes or whatnot. But performance impact, I mean, I run it here on my daily laptop as an example, and we have a lot of customers running it as well.
Mhm.
Any other questions we might
Uh,
be?
yeah, does Morphisec require any kernel modifications
No,
and any kernel considerations?
a great question, right? When you think about how Morphisec actually integrates by leveraging the kernel module itself, the eBPF kernel piece, that allows us to run code within it. And it was designed like that from the Linux team so that you could run code securely. And that gives us hooks into everything that we need access to. Everything from the kernel hooking as well as file access, both being able to identify and create or decoys, killing them if somebody tries to touch or manipulate them in any way whatsoever. So no kernel modification required whatsoever on our part.
Hmm. Yeah, and then actually that that's a good segue into the last question here, but can you customize Morphisec's decoy file deployment to like specific folders and things like that?
You sure can. And that's one of the things I love about our Linux piece, our Linux protector. Because it's intended for servers, you can customize and point to any specific folder where you want to have additional protection. Because we understand a lot of organizations have unique environments, like an NFS share, folders for specific applications. And by dropping the decoys and pointing them directly to that, it ensures that the protection mechanism is enabled on whatever folder they want to employ us on.
Hmm. Great stuff. So, appreciate your time, everyone that joined today. Appreciate the master class, Darren. This is a good segue to stop. And for those that want to know more, please check out morphisec.com. On our resource page, we have tons of resources on Linux and other topics. We also have our blog. There's a sub filter for Linux as well. And then we even have news and basically some coverage out there in the media as well, that we've been showcased by the media on our different unique position on Linux and the way that we've gone about protecting this important operating system. So definitely tune in next month for our next session and next monthly demo, and appreciate everyone's time today.